All right. So today we're going to continue talking about internal rate of return, and that is what we started with in class on Monday when we looked at how many years until a certain unrecovered investment balance had been returned. Um, Homework 7 is due on Monday the 12th. And so you should get started on that assignment so that it's not a last minute rush. And I think in general it seems like this class is pretty good about starting early. I do get questions sometimes just immediately after the class is concluded. So I really appreciate those of you who get that early start because it gives you the chance to learn and reflect. And if you get stuck on a certain problem, then there's time to get in touch with me before it's too late. So that's great. Keep it up. The project is due on the 20th of November, so you still have plenty of time to do it. I've had students ask me in the past, how long is this project going to take? And I think what I've told them in the past is a student should spend between 10 and 20 hours working on it. If you spend more than 20 hours, probably you're going into more detail than is productive. But if you spend less than 10 hours thinking about it, probably the depth of analysis included in like your research on the likely salary isn't good enough, and maybe you're not going into enough layers of detail when it comes to estimating your expenses. So 10 to 20 hours is what I usually tell people. Okay, so any questions related to the announcements before we continue talking about the internal rate of return? All right. Now, this figure is what we looked at during the class meeting on Monday. And the in-class exercise we did was looking at how an unrecovered investment balance decreases over time. And so the point of this figure was to show a balance between the revenue that was coming in and the profits that could be made based on that revenue. Remember that if you subtract out the operating expenses in every given year, then a certain amount of profit is received. And so what we were doing is we were finding a balance between the future profits for buying a food truck and the initial upfront expense of buying that food truck. And so we were looking at, over a certain number of years, at a certain interest rate, how it all comes into balance. Today we're going to look at what if you have a variety of different interest rates available. We're going to do an illustration that compares two hypothetical auto loans. This is from a while back. I took this screenshot, you can see, back in 2016. But auto rates for taking out a loan are approximately the same as now as they were then. At that time, Huntington Bank was offering a 66-month loan for an APR of 4.72%. APR means annual percentage rate, and that's where the effect of compounding is taken into effect. That's where you do include the monthly compounding effect. Star USA Federal Credit Union was offering the same duration loan, a 66-month loan, for 2.75%. And so I'm going to pull open a spreadsheet, and we're going to look at, as a demonstration, of how interest rates matter and why making a purchase with one set of interest rates maybe would make sense, but at a different set of interest rates it wouldn't make sense. And so the illustration that we'll look at is, what if you were going to buy an F-150 truck? And man, I've been shocked at how expensive these trucks can be. This is just an F-150. Now granted, it's a Super Crew, so you've got the second bench back there in the passenger compartment, but the price, after a couple of discounts kicked in, is $54,105. So let's say that you were thinking about purchasing this truck because you knew that if you put it into service, then you'd be able to generate an additional $900 per month in revenue. Now it seems like a no-brainer, right? That, boy, $900, that's so much. How could it not pay off any particular vehicle? But we're going to analyze at the two different interest rates whether you should do it, whether you should make this purchase. Now the 900, that's after the cost of fuel and insurance have already been taken out. And so it's like a net revenue, meaning that this would be the profits that would balance out the initial purchase. All right, so for this one, just observe. You don't necessarily have to follow along yourself with Excel, but I'm just going to do a demonstration here that shows you what happens if we have 2.75% versus 4.72%. Those are the two different interest rates that we have as an option. All right, so I've got some of this set up, but not all of it yet. So we know that it's a 66-month loan. So I'm going to, first of all, set up the time column. And as soon as I get a couple of these highlighted, then I can drag it down as far as I need. And you can see it's giving me a little preview of what the number is. And I want the preview to take me up to 66. All right, so we're through 66 months of the loan. And my initial amount is $54,105, and that's an outflow. And so minus 54,105. And you can see that I have a column here where I'm calculating the present value of the amount. And in the present value, it's referring up to an interest rate per month. And so let's first of all look at what if we have the APR of 2.75%? So 2.75% per year is 0.0275. And so the interest rate per monthly period then would be 1/12 of that. So here I'm going to have the interest rate per year divided by 12. So you can see the interest rate per month is 0.00229. Okay, and my initial equipment cost, I guess rather than typing it down here into the row by row, it would be maybe better for me just to type in here that it's 54,105, and that way if the dealer offers a discount or the price changes somehow, then I can just make the change here and not have to do it every row beneath. And likewise with the monthly revenue, there's a monthly revenue of $900 that we can receive. And so then here for the amount, I'm going to say it is equals the minus of this initial cost, because essentially what we're doing is we're investing in the equipment up front. And then here for the revenue each month, I'll refer up to this location and I'll anchor it, since I'm going to be dragging that down through the rest of all of the months. So to drag it down, I can either click here in the corner and hold my left mouse button as I drag it down, or since I have these numbers to the left of it, what I can do is I can just double click down in the lower right hand corner. If I just double click with my left mouse button really quickly, then it automatically fills it in as long as there's some number to the left. So it saves me from having to click and drag and getting it to line up correctly. Alright, now remember the PV function, the way that we do that equals PV, and now it wants the interest rate. So I'm going to refer to the interest rate per month, and I'm locking that location by pressing the F4 button. And pressing F4 puts in the dollar signs. And then NPER just means the number of periods from the future that we're discounting back to the present. So that's where I'll indicate the month. I'm skipping over the payment field because we're treating each one of these row by row amounts as an individual future value. And so you can see with the double comma, now it's highlighting the FV because it's saying, tell me what is the future value. And because Excel always changes the sign, I have to put in the minus of, now it's going to be the amount that's in cell B12. And I can't click on it because I've got this centered, and so the formula itself is kind of covering up where I normally would click. I guess maybe I click on the edge there. Let's see. All right. Otherwise, I could have just typed in B and then the number 11. But all right, so it's no surprise that 54,105 at month 0 has a present value that's the same because it's not being discounted any years. But then when I double click this and apply the same formula through all of the rows, you can see that we are discounting these future revenues. So $900, 66 months in the future, if you're discounting at the interest rate that applies, it only has a value of $774 in today's terms. Because remember, the time value of money says that money in the future isn't as valuable as money now. So when I add up all of this, the entire cash flow diagram, when I add it all up, that's what I'm doing here. This total present value, you can see that my formula is, it's the sum of all of the cells beneath it. And so what it tells me, this has been a lengthy setup, but what it tells me is that this is a profitable investment. Remember, present worth analysis says that if you discount the future revenues to the present at an interest rate, and then that interest, and then the amount is greater than zero, then it means that you have profits that will exceed the cost of the loan. So this is a profitable investment if we get the 2.75% loan. But what if Star USA Federal Credit Union, what if their promotion ends? And now what if the only bank option that's available is the 4.72% interest? Let's put in a different interest rate per year and see how that affects the bottom line. So now I'm going to, instead of have 2.75%, it's 0.0472. So it's a higher interest rate. Now think, before I type enter here and it changes all the values, as soon as I press enter, everything's going to be updated instantly. But think conceptually. Is it going to make this present value higher or lower? And I'd love it if somebody wanted to take a guess at that in the chat box or unmute your microphone. The present value, if we are discounting those future amounts at a higher interest rate, Andrew says it's going to be lower, and he's right. So Andrew, why is it that the present value, the total present value of the entire investment is going to be lower? What's your rationale? I don't know, but I envision Andrew is busily typing right now, explaining why it's lower. Maybe it was just a coin flip guess, but I bet it's more than that. Anyone? Why is it that the present value is going to go lower with a higher interest rate? Andrew says the interest rate is higher, so you will have to pay more to the bank and make less profit. That's a good way of thinking about it. Just from a technical perspective, you know, these amounts in the future, oops, by clicking somewhere else, that effectively is like pressing enter. So let's see. Yes, now it's negative. So the higher interest rate means that the project is not profitable. So why is it not profitable? It's because in the way that Andrew was thinking of it, now you have to give more to the bank. So more of your profits, a greater share of your profit is going to cover the cost of the loan. And so this $900 every month, it's not enough to cover the cost of the loan. The other way to think about it is just from a purely numerical standpoint. If you're discounting these future revenues at a higher interest rate, then that means they're not going to be worth as much. And so remember, when it was $900 being discounted at an annual rate of 2.75%, then the $900 was worth 7 something. But now if we're discounting it at a higher interest rate, it's not worth as much because it's being discounted more severely. And so the initial cost stays the same, but the value of those future revenues is lower than it was previously. All right. So the point is, interest rates matter. If you can get a low interest rate for financing your project, then the project is profitable. If you have a high interest rate for financing your project, then your project is not profitable. And right now, in our American economy, we're going through an era of uncharacteristically low interest rates. Businesses are able to borrow money at a really, really low price. And a lot of people are worried that if interest rates go up, then it could cause a lot of pain because businesses have sort of become addicted to cheap money. They've become addicted to it being easy to borrow funds and not having to pay a very high premium for it. So, if interest rates go up, then that could cause a real shock to the system. But this illustrates interest rates matter. Before we move forward, are there any questions about this illustration that we've just gone through and the concepts that are behind it? All right. So the internal rate of return is what we're talking about today, and it can be used in decision making. The internal rate of return is balance between the cash flow in and the cash flow out. And so remember, I've showed you the picture before, the illustration of the elephant on the ball or the rocks that were balanced. And all of those, and this scale as well, are just talking about equilibrium between inflow and outflow. And so the IRR, the internal rate of return, is that interest rate that makes the inflow and the outflow equal. So back to this illustration that we just did, there is some interest rate that makes the total present worth 0. So is it 4%? Is it 3%? Is it 0.031? We're getting closer to that magical, it's not really magical, we're getting closer to the interest rate that makes the total present worth 0. And 0 for the total present worth just means that the outflow, the initial upfront cost, is in equilibrium with the value of the inflow. So of course you know, because we've done it before, that the way that we can solve this really quickly is with data, what-if analysis, goal seek, and then we say we want this total present worth to be 0, and what it is allowed to change, it's allowed to change this interest rate. And so it will go through and it'll try a lot of different interest rates and then find the one interest rate, so 3.40%, will bring equilibrium between the inflow and the outflow. So back to this concept, what we're saying is the internal rate of return is the interest rate that will have balance between the value of the cash that's coming in and the value of the cash that went out. It's not that the same number of dollars are coming in as went out, it's that the value of those dollars is equal. Okay, so internal rate of return, it equates the equivalent worth of the cash inflows to the equivalent worth of the cash outflows. You can only calculate the internal rate of return when there are revenues. So some projects, like building a park, for example, you've only got expenses. You don't have revenue when you're building a public park because people don't pay admission to go to the park. So you couldn't calculate the internal rate of return for something where it doesn't have revenue. Or if there's only a little bit of revenue and they don't exceed the costs, then you can't calculate the internal rate of return. It shouldn't be a negative number. It doesn't make conceptual sense to have a negative internal rate of return. Solving for Excel is most easily accomplished, solving for internal rate of return is most easily accomplished with Excel, as you just saw. There's also a graphical technique that I'll show you in just a minute. But here is the analysis or the decision criteria. And you know from the first exam, I like to ask people questions like, what is the decision criteria for a certain kind of method? So if you're using the internal rate of return for decision making, then what it tells you is whether or not a project is acceptable. You can only use the IRR method for screening. And the screen is this. If the internal rate of return is greater than or equal to the minimum attractive rate of return, then you can accept the project as potentially a good option. It doesn't mean that one project versus another is the best option, it's just acceptable. But if the internal rate of return, so I star is the internal rate of return, if the internal rate of return is less than the MAR, then you should reject it, because the MAR, by definition, is the minimum that's acceptable. So here's the decision criteria for using the internal rate of return. So I star is the variable that we assign when we're solving for the internal rate of return. And the couple of ways to think about it is the rate of return that's earned on an unrecovered balance. And so if you purchase an item with your own money and you're solving for the interest rate that brings equilibrium between how much you spent up front and the revenues you expect to get in the future, you can solve for the interest rate. What interest rate is going to bring that balance so that in and out are equal? And when you do, it's going to tell you an interest rate, and that is the internal rate of return. So if you're the investor, then the internal rate of return is what you're receiving. Or if you've borrowed the money, then the internal rate of return represents the rate that you've paid on the balance that hasn't yet been repaid for the loan. So don't get hung up on the definition quite yet, because I think it'll begin to make more sense or additional sense as we do some examples and look at some concepts. On a practical matter, like when you're actually solving for it, the internal rate of return is some interest rate that brings balance between the inflows and the outflows. So you saw that on the spreadsheet where I did a what-if analysis, and I wanted to find the sum of the present worths to be zero by changing the interest rate. That was the internal rate of return. So here's a cash flow. What we could do is we could find what's the internal rate of return for this cash flow. It looks like in this business opportunity you're paying some money up front, and then you're going to get some future revenues, and there will also be some costs. And the procedure would be that you take everything to the present, and you're going to have to start off with discounting it at a guess, because when you begin this computations, you don't know what is the interest rate. It's an unknown. And so you just start off with maybe, for example, 1%. And then you discount everything to the present at 1%, add it up, and then you see, is the inflow more or is the outflow more? And you keep tinkering around with the interest rate until the sum of the present worth is equal to zero. So that will be the method that we're going to apply in today's in-class exercise. So the method, solve for the interest rate where the present worth of the revenue is equal to the present worth of the expenses. And this is the formula that your book introduced. It says that if you take all of the revenues to the present, and so you see here the factor, each individual year of revenue is going to be discounted to the present. So P/F means take it, find the present given some future value, and you're going to be discounting it at the internal rate of return, and K is just the number of years. And so then you do the same thing with all the expenses. You discount them to the present, and then anything that's already at the present, like the initial purchase price, also gets added together. And what we're looking for is we're looking for it to be equal to zero. So what is the interest rate that makes everything equal to zero at the present? Graphically, this shows what we just saw with the truck example. Remember, in the truck example, if the interest rate was low, 2.75%, then we had a positive present worth. The reason why it was positive is that whatever future revenue you're going to have, it's being discounted to the present at a smaller rate. So it holds more of its value. $900 in 66 months is worth more today if it's being discounted at a relatively low interest rate. But if you're discounting that future revenue at a high interest rate, then the sum of the present worth is going to be negative, because the initial purchase price is going to be larger than the value of those future revenues. So the internal rate of return is that crossover point. So when I say you can solve this method graphically, this is what I mean is if you put in a bunch of hypothetical interest rates, then you could actually draw this curve and find your present worth gradually decreasing as the interest rate becomes more positive. Warning, warning, students misuse the internal rate of return. I don't want you to misuse this tool. This tool is good for screening. I mentioned earlier that you can use the internal rate of return for initial screening. And what you can do is if you compare the IRR that you solve for, it's going to be some percentage. Compare that percentage to the MAR, which is also an interest rate percentage, And remember from the criteria, if the IRR is greater than or equal to the MAR, then you accept the project. If the IRR is less than the MAR, then you'd reject it. But if you have lots of options, if you have several different options, then it's not always the case that the option with the highest IRR is the best, most profitable alternative. And so you don't just want to pick which option to do based on the IRR method. That's an unacceptable way of using this technique. The technique is only for initial screening. It's for weeding out the options that are not acceptable. So you can see here that I say the IRR alone cannot identify the most profitable project. And I'll prove that to you in a future class. I think on Friday I have a quick proof that shows you that you can't use the IRR method for finding the best project. You can only use it for initial screening. Here's the other big warning or caveat. Boy, it's in bold and it's so large, and there's some underlining here, so that really is drawing attention to the fact that this is important. It's the assumption that's built into the internal rate of return. You may be wondering why it's called the internal rate of return. Like, what does that mean, internal? Well, it's referring to the assumption that when you calculate the IRR, you are assuming that all of the profits that come in are reinvested at some location where those profits are generating the internal rate of return. In other words, it's assuming that you reinvest your profits in the same project, or that you're earning, at the very least, it means that you're earning the same rate of return on the profits. And so, remember the case of the food truck, for example? If you want to calculate the internal rate of return on the food truck, then what that means is it's assuming that all of the revenue you generate from selling hot dogs, that money is going to be reinvested back into the hot dog truck. Now, maybe it's not the hot dog truck itself, but what it really means is that it assumes that you're reinvesting the funds in an option that gives you the same rate of return. So it just assumes compounding, internal compounding. That'll become more clear when we talk about a different method called external rate of return in the future. But IRR just assumes that you're taking the money and you're putting it back into the same business. Okay, so here's today's in-class exercise. What we're going to look at is this cash flow. I'd like you to discount it to the present at 7% and at 8%. And then I think what you'll find is that you have one positive value and one negative value. And we want to, with that, use the, let's see, I think on the handout I've given you there is the equation method. So, you know, when you do number one, you're going to do it with the equation method. And let me bring up the equations for your benefit. Here they are. Let me just paste them into the right spot here. All right, so first things first, we are going to use the equation method to find out the present value of, oh boy, that would be tedious. It'll just take too much time. Let's do it with Excel. And it says Excel. Yeah, forget it. All right, so let me paste this into a blank spreadsheet. And you can follow along. Okay, so here's our cash flow diagram. We want to find out what is the present worth if the interest rate is 7% and what is the present worth if the interest rate is 8%. So this is problem 1A for 7%. So I'll have I equals 0.07, and then over here for problem 1B, 1B is where we're going to do it at 8%. So I'll have I equals 0.08. All right, now for both of them, they're going to have the same year, amount, PV of amount, and then here I can just say amount, PV of amount. All right. So it looks like this is an 8-year time horizon. And what we want to know is, for this 8-year time horizon, what is the sum of the PVs for 7%, and what is the sum of the PVs for 8%. So let me pause for a moment so that you can do these calculations, and when you think you've got the right number, the sum at discounting at 7%, the sum when discounting at 8%, go ahead and type it in the chat box and I'll let you know if you're on the right track. Okay, so let me go through here and demonstrate. First of all, we have to translate the cash flow diagram into a cash flow table. So we are paying $800,000 up front, and we get $125,000 3 times, and then minus $400,000 in year 4, $292,000 in, have I missed something here? 1, 2, 3, 4, okay. 5, 6, 7, and then year 8, $377,000. All right. So now the present value formula equals PV. The rate is going to be the 7%. I need to anchor the reference, comma, N is the number of years. Skip over the payment field, minus of the amount. Okay. Ooh, that's hard on the eye. Let me change it. All right. Now drag that down. So here is all of the present values, and if I add it up with the sum function and then just highlight the range that's being added together, $26,906 effectively. Now the amounts are the same for the 8% interest, so I guess I really don't even have to copy that over or type it again. I can just do the formula here. So equals PV, and the rate I'll click up here for the 8%, and for the N I can click over on the left, skip over the payment field, and here for the future value I'll do the minus of the amount. And again, I'll change that so it's not red. Drag it down, and then calculate the sum. Equals sum of this entire range. So if I have 7% interest, the project is profitable. If I have to pay 8% interest, the project is not profitable. So think back to this figure. 7% put us in the positive range. 8% put us in the negative range. What that means is that the internal rate of return is somewhere between 7 and 8. All right, so in part 2, then we will use goal seek to find the internal rate of return. So I demonstrated that earlier, how to do goal seek. What we're going to do is, so that you don't lose your work, my suggestion is to create a copy of this worksheet. So see down here at the bottom where it says sheet? If you right click on that and then move or copy, let's create a copy of it at the end. And so we'll call this one problem 1, and then this other one is a copy of it, but I'm going to call that problem 2. And then I can play around with these numbers without affecting my original one. So, I think it's a good idea to save your spreadsheets as a reference to use on the homework and after class for studying. So if we create that duplicate worksheet just by right click and then move or copy, and what we did was we create a copy, and move to end just puts it at the very end. So now I can play around with the interest rate, because in question 2 it's saying what is the internal rate of return? Use goal seek. So the goal seek is going to be, if I change this interest rate, for example 0.071, I'm getting closer. My objective is this should be 0. I don't need, I'll just shove that out of the way. This should be 0 by changing the interest rate. All right, so internal rate of return is the interest rate that brings balance to inflows and outflows. Balance meaning that the value of the in and the out is equal. All right, so let me pause for a moment. Solve for what interest rate makes this 0. And remember, the way to get at it if you want to do it in an automated way is with the data tab up at the top in the ribbon. Data over to what if analysis, goal seek, and then use that tool to find out what is the internal rate of return. So to demonstrate, what we want is set this to be a value of 0 by changing the interest rate. Okay, and then when I click OK, it's going to instantly start plugging in lots of different interest rates until it finds the one that makes the total 0. So I click OK. 7.63%. Now, do we really need to see all those digits? Not necessarily. We can control how many digits are displayed with the this decreased decimal. So, just like this. 7.63%. If we want to express it as percentage, we just click this. 7.63%. All right, so that's the internal rate of return. What we've just solved for is the internal rate of return, I star. There is a function that will do that process for us. Let me show you the IRR function. Equals IRR. Okay, parentheses, and then it'll start giving us hints. Okay, it says values. Well, let's just select these numbers, the amounts, not the present value of the amounts, just the amounts. Close parentheses. This is looking promising. We increase the decimal, 7.63%. So what it's doing in this IRR function, it's doing several steps all at once, kind of internally, inside of the spreadsheet, without you seeing it. What it's doing is it's doing all of this. It is taking the amount, finding the present value, and then it's solving for an interest rate that brings balance between the inflows and the outflows. So it's kind of an automated function. So in the homework, sometimes I'll tell you to solve for the IRR, and I'll say do it with the PV of amount method, you know, so I can see your work. You can also check the internal rate of return using this IRR function. Any questions about how to use the IRR function? Let me do it again, just because it goes so quick. Equals IRR, and then when I start the parentheses, it's saying, tell me the values. And so it should include all of the values, including the amount that's already at the present. So that's a little bit different from the NPV function, which you may also remember. In the case of the NPV function, you only put future amounts. But here for the IRR, it's going to look at the first value it sees in this range, and it's going to know that's in year 0. And then the second value that it sees in the range, it's going to know that that's the amount in year 1, and so on and so forth. And so it will discount those future values to the present at a variety of different interest rates. It'll just chug through it, and it'll try out a lot of different interest rates until it finds the one that causes the inflows and the outflows to be equal. So in our case, it was 7.63%. So that's the IRR function. Okay, last question is on a different topic. It's on the topic of bonds. Okay, so Practice with bonds because you have a couple of bond questions on the homework. So I wanted to give you another question related to bonds and then show you the solution to this one. You want to achieve an annual yield of 12%. And this bond, it says, pays monthly interest. So for the next 5 years. So there's going to be 60 periods. And so N is 60 because it's monthly interest for the next 5 years. So N is 60. And you want to achieve an annual yield of 12%. And so the I that you're trying to achieve is 0.01 because it's 12%, and then the interest per period, you divide the 12% by 12. So what you should do is, with this formula, you're trying to figure out how much should you pay for the bond. What's its current value if you want to achieve a yield of 12%. And what it says is it pays $50 a month for the interest. And so $50 a month is R times Z. The product of R and Z together, that's telling you the value of the monthly payment. Normally, in a lot of cases, the bond would say what is its face interest rate. But here, they've already told you what the value of the monthly payment is. And so you're going to discount those monthly payments to the present with the A/P operation at an I of 1%. And then you also need to discount that lump sum payment of $6,000. And so C is $6,000. Let me give you a moment to calculate that, and then I'll show you the solution. So the P/F formula, find P given F. So that's 1 plus I to the minus N power. So I is 0.01, N is 60, and we want to find what factor should we multiply the 6,000 by. So it's going to be 6,000, the lump sum value, out in 60, what is it? Yeah, 60 periods in the future. So we're discounting it at 1% per period. And then we're also discounting the recurring $50 payments. And there will be 60 of those $50 payments, and we're going to find out the present value of the series. So let me show you. So you can see R times Z is 50. It's, rather than having you determine the value of each of those periodic payments, it just said it outright that you're getting $50 in interest each month. C, the lump sum, is 6,000, and you can see it's 60 periods. So at 1% interest per period, then we can calculate the factor for find P given F, and that's the factor that the $6,000 lump sum will be discounted at. And then here's the formula for find P given A, and the factor for that, 44.95. So we multiply the $50 times 44.95, and you can see that 60 payments of $50 each month in present terms is worth $2,247. So that's the value of the interest payments. And then the value of the lump sum in today's terms is $3,302.70. So if you combine those two pieces together, then the value of the bond now, in order to achieve a 12% yield, is $5,550.45. And so that's what you would be willing to pay in order to achieve the 12% yield. So I wanted to give you that just because I think it will help you to see one of the homework problems a little bit more clearly. Speaking of which, the homework 7 is due on Monday. Reminder about the project. So that's all I have for you today. I'll see you in class on Friday. Have a good one. And if you have any questions, of course, you can always reach out via email or give me a call on Teams.